In this video, I'm going to show you how to calculate and interpret predicted probabilities and group membership in the context of a binary multiple logistic regression. And I'm going to show you two ways to do it. One, which is very simple and easy because you're going to use the SPSS menu options. And then a second way, which requires a little bit more work, but ultimately will help you calculate standardized beta weights. And so I think it's useful to know how to calculate those predicted probabilities through the regression equation. So to do it the easy way, I'm going to analyze regression binary logistic. And I've got the variables already entered here because I've done the binary logistic regression earlier. I just didn't do anything with the predicted probabilities or the group membership predictions. So click on Save. And you'll see a section here, predicted values. And if you click on here, you'll get the probabilities. And if you click on here, you'll get the group membership values. Click Continue and click OK. Now SPSS has rerun the binary logistic regression, so there's nothing new here in comparison to what I've done in the previous video. But what is new is that SPSS has created two variables. One which is pre_1. These are the predicted probabilities associated with each case. So for ID1 or case 1, this person had an absenteeism score of 36 and performance of 6.57, and they actually left the company. So the turnover was equal to 1, which is leave, and the predicted probability on the basis of their two independent variable values was equal to 0.53 rounded. And 0.53 rounded even further into either 0 or 1 on the basis of interpreting a value equal to 0.500001 or greater as a 1, then you would get the group membership prediction, which is a leaver in this case. Now here's another case where the predicted probability exceeded 0.50, and therefore I would interpret that to suggest that this person is at a greater probability of leaving the company than staying. And sure enough, that's the prediction when you round it fully based on the group membership. Now here's a misprediction in the equation on the basis of the data, and you can see that this person's absenteeism was 52.75, performance of 6, and the regression equation would produce a predicted probability of 0.67, which suggests that they would be a leaver. And when you round that in full terms, either 0 or 1, it's a 1, but actually it was a 0. This person stayed in the company. So that is a misprediction comparing predicted probability and group membership and the actual value. So here's a value where it's less than 0.5000 and it's exactly 0.35701, which is predicting that this person is going to be a stayer. And that is where the 0 comes from, rounded into a dichotomous value, that's 0 because it's less than 0.50, and that is consistent with the actual observation in the real data. So that person was a stayer and they were predicted to be a stayer. So that is calculating predicted probabilities, and this is the group membership, and you could always calculate the difference between the actual leaving or staying scores and the predicted leaving or staying scores, the group membership scores, based on the prediction. And if you do that, what you'll get is the percentage of correctly classified cases, which is reported automatically in the output in SPSS. So you don't actually have to do that manually, but that is what that would correspond to. Now the longer approach to calculating predicted probabilities, which is ultimately going to help calculate a standard deviation value that will be necessary for estimating standardized beta weights, involves 3 steps. And the first step involves using the actual logistic regression equation and getting predicted probabilities that way, but they're on a scale that is not fully appropriate for the purposes of interpretation and using in the calculation of a standardized beta weight, which I'll show in a separate video, but you will have to know this step because you otherwise won't be able to do the standardized beta weight. So the first step involves transforming values into predicted log odds. So go into Transform, Compute, and I'm going to predicted log odds. And this first step of the 3 really involves just creating the predicted values on the basis of the regression equation. And as I mentioned in the textbook, these are not fully interpretable predicted values because they're on a log odd scale. That's the way SPSS does the analysis. And so these predicted probabilities I'm going to create are not going to be exactly the same as these predicted probabilities here. So let's do that. So the intercept is the first step. So I need the intercept just like I would for a multiple regression. So 3.689. So 3.689. That's the starting point of any regression equation, plus, and now I need the values associated with the first independent variable, absenteeism, and I'm going to multiply that by the unstandardized beta weight, which corresponded to 0.015. 0.015. Plus, now I need the second independent variable, performance, multiplied by the performance unstandardized beta weight, negative 0.631. Negative 0.631. So this is exactly what I would do in a multiple regression if I wanted predicted values. This is the first step, and as I mentioned, these are going to be on a log odd scale, so it's only the first step, not fully interpretable. See, this is the predicted value here expressed on a log odd scale, 0.019, when really it's 0.52807. So to get these values on an appropriate scale, I need to get rid of the log odds, and the next step would involve exponentiating these values. So to do that, go into Transform, Compute, and I'm going to call this Predicted Odds, because now I'm getting rid of the log component. And to do that, just write EXP and add the predicted log odds in parentheses, and then OK. And that has produced predicted odds. And now I just need to do the final step to create the predicted probabilities. And that is Transform, Compute, Predicted Probabilities is what I'm going to call this variable. And that is with the formula that I specified in the textbook. So predicted odds divided by, open parentheses, 1 plus predicted odds. Close parentheses and click OK. And that has given me the predicted probabilities that are exactly the same as the predicted probabilities I got in the menu option. Let me just change the decimal place to show that that is the case. Add the 4. And I have 0.5236 versus 0.52807. If I use the unstandardized slopes or beta weights to a greater decimal place, say 5 or 6, I would have got predicted probability values even closer to what SPSS produced. So it's really just a rounding issue that I didn't get the same predicted probabilities exactly as that produced by SPSS. So that should help give you some understanding of the nature of predicted probabilities. They're really essentially the values that are predicted from the logistic regression equation. It's just that the results reported in SPSS are reported in a log odd scale, and therefore the predicted probabilities are also produced in that way. And so they need to be transformed through a couple of steps in order to get them on a scale that's interpretable. Now, as I mentioned earlier, this step here of getting the predicted log odds is important because I'm going to use these values in order to estimate a standard deviation, which will ultimately help me create standardized beta weights to help with the interpretation of the binary logistic regression.